Hi Brad, here's a screencast for 7.4 as we go through it in class. So we want to know how long is the sine wave from 0 to 2 pi? Like how long is the actual curve itself? So if you would like trace it out, like how many like units would it be? Right, if we'd stretch it out into a single line, how long would it be? So the usual meaning of wavelength is the period, and so Louis was right when I asked him earlier. He's like, oh, it's 2 pi, like that's how long it is. But I really want to know like literally the length of the curve. So what we can do is define this. Oh my god, my voice. So what we can do is have a point, and I'm gonna call it P. Another point, call it Q. And then make this little triangle, and we can kind of like, if we make the triangle small enough, it will actually like fit the curve perfectly.
Right. So you just make tiny small triangles.
Yeah.
So it's like 1/2 the integral.
So here, how do we find the length of the hypotenuse? We're gonna like
square root of x squared plus y squared.
Exactly. So I'm just gonna call it delta x because that's a small change in x, plus delta y because that's a small change in y. That will be the length of the hypotenuse. And so if I make tiny, tiny, tiny triangles, and I just add up all of the hypotenuses, hypoteni, if I add up all the hypoteni, I can get the length. I can like literally trace the whole curve. So that's what we're gonna do. But how long is the curve itself? Well, I mean, you add up all of the hypoteni. Wait, what'd you say?
He said he had like big pencil, which is very large.
Okay. So AKA when we take this like summation, that's the same thing as doing the integral. Taking the summation, same thing as doing the integral.
Oh.
Ah, okay. So if you straighten it out like a piece of string along the positive x-axis, summation, sigma, you do.
It's like if you add up all of them. So then why don't we just write integral? Because it's a different thing.
That's what we're gonna end up doing is the integral. Because you learn about summations in pre-calculus, and then you learn about integrals in calc.
Okay, yeah, I mean we did, but like you'll also learn it in physics.
That's awkward. If you straighten it out like a piece of string with one end at 0, how long would the other end be? So that's what Daniel said. So the arc length of a smooth curve, if we have a smooth curve where, like literally all this is saying.
A little bit, just so I can see something.
Oh yeah, sorry. So all this is saying is like, hey, if I have a curve that looks like this, and I'm gonna say it begins at A comma C, so right here, and ends at B comma D. What's wrong?
It wasn't organic, I just did all of it.
I've been having issues lately. But if I use the dongle, it's worse because then it's a seizure and has red flashing. So choose your poison. All right, so we have A comma C is 1 point. Our other point's B comma D. As long as like A is the one on the left side and B is the one on the right, as far as my X values, and as long as C is less than D, so it's like smaller, so they can't be at the same height. So you can see like this one's actually like shorter than that one.
So do you have to use both of these functions for one line? Like L equals A to B, L equals C to D? I mean, B to A, D to C.
We should get the same length.
Okay, but...
But one is a function of y, one's a function of x.
Right, and you can go about it both ways.
Yeah, but also from what we just learned, if your curve is... Right, if your curve looks like this, actually, hold on. If your curve is something like this, you don't want to do a function of x because it's not a function because it doesn't pass the vertical line test.
So you're gonna want it.
So that's when you do it by y,
Okay.
versus like this function of x.
Right.
Cool. All right, find the length of the curve y equals sine x from 0 to 2 pi. So, cool.
So why is it 1 plus dx dy squared? Because I know you derived it from Pythagorean's theorem, but like, where does the 1 come in?
Let's see.
Is the 1 the bottom length?
Yeah. And the dy dx, how it's
So you're just
changing.
keeping the size of the triangle consistent,
Yeah.
or at least the length across x. Just one each time.
Hold on. Let's see.
Because if it's the square root of x squared plus y squared, then x squared would be equal to 1. So x was equal to 1.
Yeah. Okay. We could look at the proof. Okay, so we're gonna be using this top one. dy dx. I mean, it's just the derivative. Cool. And you asked, wait, what'd you ask? Why it was 1 plus?
Yeah, because then wouldn't the bottom length of the triangle be 1 every time? The length of 1. So that's not that accurate to find the.
I feel like they did a dx squared plus dy squared, and then then they did some voodoo to like move it over.
Oh, okay. So it's not going to be like this
Not gonna be-
ridiculously large length that's going to give us an
Yeah. Because like here, this change of x literally is dx, and delta y is literally
Right.
dy.
So they just did some voodoo.
Right. And I feel like that's why we say the proof is on 413.
Thanks. It's not.
I can
Some other scientists.
I'll look at it when I give you guys a break. I'll make sure that that's what the inkling I feel like it is.
Right.
I'll double check when you're on break.
We'll look at it.
All right, so
I
here,
trust it.
let's go ahead. Let's draw this. So sine from 0 to 2 pi.
Levels of dedication.
It's a beautiful curve. Okay,
Gorgeous. Gorgeous.
from 0 to 2 pi.
Wait, Brad.
But working the polls, which is why I'm screencasting.
Hi, Brad.
Yeah, hopefully he watches it.
Hopefully he's definitely watching.
It's gonna take like 2 or 3 hours to upload. Yeah, for every like minute of screencast, it takes like 2 minutes to
My
upload.
curve is so uneven.
Okay, so if we're doing y equals sine x, what is the derivative? Okay, and so if we're doing dy dx squared,
It would be cosine x squared.
cosine squared x, yeah.
Yeah.
Why is it that it's squared, cosine squared?
Because you don't want.
If you put it over here, then you're gonna think you're taking cosine of x squared.
rather than like
Got it. That's so clever.
I think I explain that about at least once a day for the past since August.
To us.
No,
It's
I
just
kinda-
like you've explained it to us once because I think I asked like at the beginning of the year.
it's fine. People ask me all the time and freak out.
I've just always kind of think.
All right, so we know what dy dx squared is, so we can just go ahead. Let's find the length. It's gonna be integral from, what's my 2 bounds?
0 and 2 pi.
Sweet, 0 to 2 pi. And then it's going to be the square root of 1 plus dy dx squared. So here that's going to be cosine squared x. Oh my gosh. Do we know what this is equal to?
It's equal to sine
Let's see.
squared.
It would be negative sine squared. Oh, yikes. This is nasty. Okay,
What
so
would be
we...
negative sine? Oh.
Yeah, 1 plus cosine.
Maybe we just leave it like that and integrate.
Yeah, you use your calculator.
Yay!
Oh, wait a second.
Yeah, I don't know how you do it.
Because this wouldn't be negative sine.
It wouldn't be negative sine?
No, because negative sine is cosine squared x minus 1.
Why would it?
Why wouldn't it be?
Why would it be? Because remember the identity that said
But they're gonna do that.
sine squared x plus cosine squared x equals 1.
Right.
And then you like move it around and stuff, and you can like get like stuff like this if it were sine minus. If it were 1 minus cosine squared x, we would be able to make it sine squared x. Quick up.
Alright, do you guys want to plug this into your calculator to prove that you can do it? I don't just assume you know how to use your calculator.
I mean, I know how to plug it in.
Do you guys have your calculator? Just try once, just, you know, humor me. Will not assume you know skills. Cannot assume.
Take them off calculator.
Is that your sister?
Yes.
Because
Sam is an ambiguous name.
Yeah, I never remember like when I was little, like Sam being like a girl's name, but like now you hear like so many girls' names. It's rad.
Well, it was always like Samantha. You call him Sam.
Thanks, Sam.
Left it for you?
Oh, she didn't? Here, you can do this one.
I just want to make sure you know how to put it in.
We'll do it together.
Okay.
Cool. Okay. What's the next one? And then what we have next?
Square root.
And I'll do the rest.
Oh my god. You love 0 period. Go Daniel.
Wait, where'd the rest of the
I know.
No.
Yeah.
I'll do it.
Yay! Wait. Yeah.
Did you get it?
Sweet. Wait.
Did you get it? Which one do you have? The TI-83?
The exact same thing.
Yeah?
84. Yeah.
Okay, sweet. So you do know how to do this. Just making sure. I don't want to, you know.
My collective knowledge knows how to do it. I don't know if I.
Yeah, I don't think I can
know
do that one.
Well, okay. Notice that this one has no calculator. Louis, read this one. Read this one out loud.
Find the exact length of the curve analytically by anti-differentiation. You will need to simplify the integrand algebraically before finding an anti-grid. No calculator! No.
Okay, let's do this. So, first step. What do I need to do? First step.
Follow the proof though. Good idea. Protect the grid.
Okay.
I mean, you take DDX both sides. So,
okay. And then.
3/2. That's that question.
No, you're fine.
Moving forward. Maybe.
Now we take the integral, right?
We have to square it.
Oh, yeah.
Don't forget, yeah, the equation's literally the squared. No, you're not. You're in this class. You're doing fine.
Stupid idiot. I'm so dumb.
So we just square every single thing. So it's going to be 9 over 4x.
Most genius.
And now we do the integral. Alright, so we know L is equal to, well, what's our bounds? We're going from
0 to 1.
Yeah, it literally tells you. Cool. You know, boost that ego. 0 to 4. You got that one right. And then square root 1 plus, let's see, dy dx squared. Well, we already know what that's going to be. It's going to be 9 over 4x dx. Cool. Am I okay to scroll over to the right? Okay, because I'm gonna when I'm doing the problem, I'm gonna go down, but there's like an intermediate step, so I'm gonna do it to the right. Did I do this pink? Okay. Okay, so we cannot use a calculator. How do you do this in a girl? Oh my god.
Lots and lots of tears. I'm actually not.
Yeah, just
Oh, you probably use substitution.
Oh, good job, Louis.
Oh, I get it.
What should we have as u?
1 plus 9 over 4x. Like, is that what you have to do?
Yeah. And so then, and then du.
is 1. Whoa. Did you draw that?
Yep.
No, you didn't.
I didn't. I didn't.
Du equals 9 over 4.
So 4 over 9 du is equal to dx. Okay. But we also, would it be easy to find new bounds, or would it be hard to calculate them? Like, is it hard to plug in 0 and 4 into my little let u equal? No. And so I could pretty easily find new bounds. That way I don't have to plug back in this nastiness.
So that's how you figure out.
Maybe not officially. Sometimes I give you hints that may not be what mathematicians say, but I will not give you hints that will cause you to regret what I said in later classes.
Right. Thanks, Miss O.
I won't tell you things that are not true and will not work every time. Sorry. A little bit of a times 4. So this is just 1 plus 9, which is 10. Cool. Okay, so we...
Wait, I didn't get the answer.
Huh?
How? Oh, 10, not 2.
Did you say tau?
You said 2.
Oh, okay. Whatever. Alright, let's keep going.
I don't speak well.
No, it's fine. I don't either, clearly. Whenever people say, whenever I say garage sale, they think I'm saying grad sale. Like it's a graduation sale.
Grad sale.
I don't say grad, I say garage.
Garage.
Anyway, let's keep going. Bradley doesn't hear about our antics. Okay, so this 4/9 dx. This 4/9 dx, or I need to plug this in for du, so I'm going to bring it out front. So I'll have 4/9 out front of the integral going from 1 to 10. And then my equation will just be u to the 1/2 du. So that makes it much, much nicer. Confused? Your question? So this makes it much nicer. We know what the integral of u to the 1/2 is.
Wait, I'm trying to figure out how you brought that.
So since this is what I put in place for dx. And then since 4/9 is a constant, swing it out front.
I get it.
Cool.
I didn't know before, but now I do.
Don't do that. All right. So let's see. This is going to be equal 4/9
49.
times.
Pi.
Let's see.
3 over 2. Brad, if you're listening to this,
3 over 2.
take it over, but you name it. Well done. We need your help. Take the one true savior.
I don't think he can hear you.
Say
Bradley.
Right, save us on the screen.
No thanks.
But Brad. That's
No, it's not.
Good morning.
Just a second.
Yeah,
Okay. So are we confused why u to the 1/2 goes to 2/3 u 3 over 2? Because you're going to be dividing by 3 over 2, which is the same thing as multiplying by 2/3. Okay, now let's evaluate it. So let's see, this will be 8 over 27. I'm just combining the two fractions.
It's a terrible fraction. You know that?
You're a terrible fraction. Let's see, from 10.
It's not just a third. No, it's almost a third. 9 would be a third.
It's almost.
Bad, right? No, what's 8 times 3? What's 8 times 3?
24?
Isn't that 24?
No,
That's
27.
Oh.
Because notice it was 9 times 3 on the left.
No.
Yikes. Basic math.
Yikes.
Yikes.
That is a good writing.
Okay. I mean, the answer is not going to be much greater. Okay, just letting you know.
If you said I'm in blended learning. Hey, that's what I said when you like. That's what you said. I didn't say anything derogatory. Yeah, okay.
Alright.
Don't
forget, this is square root of 10 cubes, so square root of 10 times square root of 10 times square root of 10. This is it. I mean, this is as nice as it's gonna get.
Disgusting, I quit. Okay, next problem. How do you
Oh shoot. Hold on.
Wait, how? Oh, 10.
Yeah, wait, how do you get
Because 3 over to the exponent 3 over 2. Well, that's
really gorgeous.
Oh, I get it.
okay. Like start explaining.
By the way.
Well, all right.
First part.
Yeah, because the to the 1/2 is a square root, and 3 is your cubing. So your cubing is square root.
Dude, Rabbi Rambam, oh my god.
All right, let's keep going. So b
There's so much math in here.
x to the 4th over 4 plus 1 over 8 y squared from y1 to y2. So here clearly we're going to be going in terms of y, because we're going from y equals 1 to y equals 2.
Okay.
Going from y equals 1 to y equals 2.
So it's like the other way. It's the other one.
Just FYI, another way to write this guy is 1/8 times y to the -2. Just so if you remember that.
Can't we just
Alright.
common denominator and then like cancel a whole bunch of shit out? Right? Oh, but that wouldn't work because then like what would happen? Yeah, okay. I see.
Yeah. Alright, let's do this. So first step, dx dy. So what's the derivative of this?
The opposite of the integral.
Okay, sorry. Y to the third. Just y to the third.
Mm-hmm.
What is that like?
Why is it y to the third?
Why is it -1 to 4?
Okay, my question is like, why wouldn't it be y to the third over 16?
So isn't it, let's see, the power rule is we do like x to the n minus 1 times n minus 1.
You were really simple and figure right out. X squared.
Derivative.
Yeah.
That makes so much more sense.
What?
I thought we were taking the integral and I'm like, what?
Wait,
No.
girl, crazy.
Oh, that was really weird. But I don't do weird things, so like,
Are we confused how we got this?
whoa. No, I'm just
Daniel, how do we get from y to the 4th over 4 to y to the 3rd? What do we do?
We multiply by 2. We multiply by -2. And we bring down 2.
Oh, okay. I was just talking about the beginning, but that's fine.
Oh, okay.
The one you asked about.
No, not that one.
Okay.
So how does start meaning is it? That it's not the 8 o'clock
Don't do this to me.
yet, right?
As you can see, I just gained another class to teach today.
I'm very sorry.
Yeah.
Let's cancel your next period.
Yeah, okay. Alright, so we have to square this. So later we're going to have y cubed minus 1/4 y to -3, and we're squaring it.
Oh, it's terrible. That foil.
Yeah.
Ew. Foil. Are you kidding me? Gross.
I'm trying to teach my sister how to foil. She's
Like, how do you do this?
Do you want me to show you each step?
I still say F.
no way.
You're kidding in my head, yeah. Not first.
Yeah. But you're not wrong, you do have to foil it out.
Like I have to visualize it as 2 separate functions, or as 2 separate binomials. My basic math skills are not there.
You just weren't pre-algebra very
Alright,
early.
let's foil.
I just like didn't pay attention. I like geometry was very hard.
Geometry was so hard. Like geometry in itself, like actually like is really hard. No, it's actually very easy.
No, it's so hard.
It's very intuitive for me, but like the math behind geometry is very difficult for me, or was very difficult for me at the time. Oh my god, that is disgusting. That is the most gross thing I've ever seen.
No. The Y's cancel out.
But like right now it is.
Well, I didn't do that step. I just went straight to the end.
Try to make sure you see it.
It's not lazy, but like, I'm lazy. I'm efficient. I'm efficient, I'm not lazy, I'm efficient. God, I love euphemism.
It's fine.
I don't even know what that is.
It's like when you make an ugly thing less ugly. Like instead of saying someone died, they passed away. That's a euphemism.
So it's like.
Daniel, you're ugly. The euphemism of you're ugly would be, Daniel, you don't look like yourself today.
No, I get it.
There's a portion inside the integral.
You're ugly.
There's a portion inside the integral, inside the square root, where we do 1 plus dx dy squared. Okay, so what would this be if we added 1? I just want to like kind of like skip a step. If I would add 1, it would be y to the 6 plus 1/2 plus. Oh, so it doesn't really change anything, but I just want to explain what I'm gonna do. Okay.
I'm sorry.
Did you say you're confused?
Rewrite the problem.
Yeah.
All I did was change it to be a positive because I added 1. Okay. Yeah?
Wouldn't you have to do that after you squared
We
it?
already did square.
We squared it. This is it squared.
So cool.
Oh, sick.
Yeah, calling me.
Okay.
That was
So-
funny.
so I'm gonna say L is-
You go back to that for 1 second.
Yeah.
I didn't even realize
That what we what?
that I was making fun of him. I said, "Oh, sick, Brad, don't." Oh no, I ran out of paper.
I miss Michael Bryan.
I don't.
From 1 to 2, take the integral, square root. I don't need to do 1 plus dx dy squared. I already added 1. So I'm going to write out what my dx dy squared was. Y squared, oh I'm sorry, y to the 6 plus 1/2. Minus, let's see.
Because you wanted all the furniture. But why did you do that? Like, I saw your room a couple days ago. Last week, days ago. Yeah, it didn't happen this weekend. Oh, right. It's so sick. Yeah.
Okay. So now what do I do?
Lay down and cry. Use substitution.
Well, there may be one thing we could do before we do that.
Combine like terms.
The line.
Can I get rid of the squared? The square root?
Oh, you definitely can.
Square root. Don't you hate it when you're like writing a problem in terms of y, and then halfway through you start writing x's?
Yeah, I'm really trying to make sure I don't do that. So notice the square and the square root go away.
What? Okay, very much.
The multiply and make it times. Where's the power of one?
Wait, I shouldn't have a 4th in the middle.
There is a fourth.
I shouldn't have it.
What are you doing? Oh, bring it back.
Stop whining. You want some wine? This would milk today. I don't drink milk every day.
Okay, so
So how can one
if I would FOIL out this, you would get 1/2 because we'd have y. We'd have 1/4 y to -3 times y to the 3 plus 1/4 y to -3 y to the 3.
Why?
It's like how we got the half in the first place. Because remember, this is like what we started with. The difference is here, instead of having a negative half in the middle, we have a positive half. So instead of having a negative 1/4 y to the cube, we have a positive negative
Well, that
1/4.
doesn't really explain to us why we get the answer. That just shows like some correlating thing.
But
What?
try and FOIL it out yourself.
But like, how do we reverse FOIL like that? I forgot how to reverse FOIL.
Yeah, reverse
Factor?
FOIL like that was pretty funny. Yeah, factor.
Yeah, so I don't know how to factor or anti-FOIL.
So
Only
Yeah,
anti-reverse
consider it
negative FOIL. Anti-reverse negative FOIL.
it's like, okay, solve a y to the third, y to the third. Somehow they need to like add like add to a half, multiply to 1/16 y to -6.
Whoa. Okay.
Because these two
Oh shoot.
multiply to 1/16 y to -3.
Not ourselves.
So I'm like showing you the way.
That was like Louis. That was Louis' question every day last year. So how would we do that by ourselves?
Like, I see that you did that. and
You
it makes
learn the
sense.
pattern and you start recognizing it.
And that was most cases.
Are you sure about that?
Was it?
Basically.
Well, that's
not
true.
word for word.
Like, how did I learn it? That's how.
She's just like practice.
Yeah.
Well, like, how do I start practicing if I don't know how to do it in the first place?
Doing it
Cool.
now.
Still press the AP things.
Me too. Just barely. You have 5.
The whole.
Can we finish this problem, please?
Okay.
Oh, that's so much easier now. That makes me great. Couldn't we honestly just add like 4/4 to the y side and just cancel out the y's?
4 to the y side. What do you
The
mean?
y. Okay, so sorry, that didn't make much sense. We just multiply y to the third times 4/4.
We'd have y cubed plus y to -3 all over 4. But in order to cancel them out, we have to multiply y cubed and y to -3. When we multiply them, the exponents will cancel each other out. But when we add them, we just have two bases we're adding together. Okay.
No, but it will be part of the same function at that point, right?
Oh, I did that. I made it still.
Like if
Yeah.
you 4 plus y. Oh yeah, I think that's they're added together.
Okay, cool. So we did this right. Yay. Alright, so that's half the notes.
Cool. So these.
This is half. And we're finishing like the other page today. You guys wanna take like a
Oh my gosh, really please.
let's take a break, I'll pause.